is the kind that he said we would get to in class. So on the video notes, he stopped on this one and said we'll get to it in class. Okay, notice that this one is already kind of in that last step. It already says sine 2 theta equals root 3 over 2. Can you see that? It already says sine 2 theta equals root 3 over 2. And we're looking for thetas between 0 and 2 pi. Now, I want to point something out at this point. Remember I said if they're all 2 thetas, that's okay. This is an equation where they're all 2 thetas, so that's okay. But we want to remember that when we're thinking about our unit circle here, and we're looking for what angles have a sine of root 3 over 2, we're actually finding what 2 theta equals. We're finding what 2 theta equals, okay? So let's do that real quickly. And I'm going to put this a little bit lower on my screen, I think. I give myself a little more room to work here, okay? And we know there's going to be 2 different places that that happens, okay? Alex, where is my sine root 3 over 2? Where does that happen? Where's my y value, root 3 over 2?
4 pi over 3.
So at 4 pi over 3 down here, my coordinates are -1/2, negative root 3 over 2. So I want that to be positive. So it'll be up here at pi over 3, and where else? There's one other one. So if my y value is positive here, positive root 3 over 2, it'll also be positive root 3 over 2 here at 2 pi over 3. Can you see that on your unit circle? They both have it, okay? So this is going to be at pi over 3 and at 2 pi over 3. Okay, everybody with me? Any questions for me so far? Because this is going to be important. I want to make sure we're all okay here before we do what's different about this one. Okay, so. So we were looking for the angles whose sine is root 3 over 2, and the angle whose sine is root 3 over 2 is pi over 3. Okay, so like we'll show it as an extra step tomorrow, and what that extra step would be, we would be doing sine inverse of root 3 over 2 equals 2 theta. Okay, we'd be looking for the angle whose sine is root 3 over 2, and that is 2 theta. So that's what we're doing. We're still doing that step. We're just not showing that step, but we'll show that step tomorrow. Okay. So that's why I'm putting 2 theta here. This is what 2 theta equals. Okay. All right. So remember that our equations here are telling us what 2 theta equals. Here it says it wants all thetas between 0 and 2 pi, which means we need to be looking for all 2 thetas between 0 and what? Okay. So if you multiply this whole little domain restriction by 2, that'll tell us if my thetas can only go up to 2 pi, then my 2 thetas would go all the way up to 4 pi. Can you see that? Okay, we're just doubling that whole equation, just multiplying that whole equation by 2. So we don't want to just look for the first time around the circle. First time around the circle gives us these 2 angles, okay? Pi over 3 and 2 pi over 3. This is our first time around. First time around the circle, meaning around the unit circle. But this is where we need to remember, and this is why we did our warm-up, we want to think about those coterminal angles. Coterminal angles. Since our equation solves for 2 theta, we've got to look for 2 thetas that go all the way up to 4 pi. We've got to go all the way up to 4 pi. And so far, we've just looked our first time around from 0 to 2 pi. Can you see that? All right, so for our second time around, how do we find those coterminal angles? For the second time around, for coterminal angles, we're going to add 2 pi. We're going to add 2 pi. Remember we said you add or subtract 2 pi to get your coterminal angles? Okay, the second time around the circle is going to start here, go all the way around, and still end here. So it's still going to be coterminal with pi over 3, but it's going to be pi over 3 plus 2 pi. So let's try that real quickly. If we want to do pi over 3 plus 2 pi. I can do this as scratch work here on the side just to see what pi over 3 plus 2 pi is. First of all, let's see what 2 pi looks like over a common denominator of 3. What does 2 pi look like over a common denominator of 3? If I put it over 1, okay, I'd have to multiply it by 3 over 3 to get that common denominator. So that would be 6 pi over 3. Can you guys see that? That 2 pi equals 6 pi over 3? So when I say I want to add 2 pi, that's going to look like pi over 3 plus 6 pi over 3, which equals 7 pi over 3. Okay, so the second time around, 2 theta will equal 7 pi over 3. 2 theta will equal 7 pi over 3. Okay, the second time around, two theta will equal, what's 2 pi over 3 plus 2 pi? Remember, we said 2 pi is just 6 pi over 3, so some of you can probably do this in your head. 2 pi over 3 plus 6 pi over 3 will be 8 pi over 3. And I got that for my second time around by just adding 2 pi to both of my angles, okay? So that second time around, that one would be 8 pi over 3. The second time around, that coterminal angle would be 8 pi over 3. Okay, so why did I go 2 pi times around? Because I was getting 2 theta, so that's going to go 2 times around, so it's going to go all the way to 4 pi. Questions for me about that part? Okay, if we can understand that part and set up our things, then finishing the problem from here is easy peasy. Okay, so let's go ahead and do this real quickly. All right, so I've got 2 theta equals pi over 3. Last step to get theta by itself, I'm just going to divide both sides by 2. Dividing by 2 is the same as multiplying by a half. That gives me theta equals pi over 6. Okay, dividing by 2 is the same as multiplying by a half. So that gives me theta equals pi over 6 for my first one. Same thing on the next one. I'm going to divide by 2, which is the same as multiplying by a half. My 2's cancel, and that gives me theta equals, here my 2's cancel as well, so that's going to give me pi over 3. On the bottom, same thing. I'm going to divide both sides by 2, which is the same as multiplying by a half. The 2's cancel. I get theta equals 7 pi over 6. I'm going to divide both sides by 2, which is the same as multiplying by a half. The 2's cancel. That gives me theta equals, 2 goes into 8 4 times, so that's going to give me 4 pi over 3. Okay, so I just solved those 4. Once we had those 4 set up, the 2 for the first time around and the 2 for the second time around, then I just went through and solved each of them for theta. Okay. Last step, we're just going to put them in order from smallest to largest. So my answer is going to be theta equals, and this is where it's helpful that we've got first time around and second time around, because what'll be from the first time around will be the smallest, pi over 6, and then pi over 3. From the second time around will be the next two, 7 pi over 6, and 4 pi over 3. Now, I want to point something out. So let me see if you've got questions first, and then I want to point something out about our answers. Any questions on how we got that or up to that point? Okay, look at our answers. Our answers are all between 0 and 2 pi. Our answers are all between 0 and 2 pi. Our biggest one is 4 pi over 3, which is still less than 2 pi because 2 pi is 6 pi over 3, right? So all of our answers did come out to be in the domain that we were looking for, between 0 and 2 pi. If we had just done our first time around, we would have only gotten half of our answers. We would have missed the other 2. So you have to make sure if you've got a b value other than 1, you've got to adjust your domain where you're looking for, the interval that you're looking for, to make sure you pick up all of the answers. Think about this original equation. This one is moving 2 times as fast. It's 2 theta, so it's going 2 times as fast. So we expect twice as many answers. And we're going to pick up those extra answers by going a second time around. Because if theta is between 0 and 2 pi, then 2 theta is going to be between 0 and 4 pi. Okay, so that's why we did a second time around. Questions for me on that one? All right, I have another one of those for us to practice because that was kind of a lot, okay? So questions on this one before we try another one just like it. All right, let's try another one. Did you need more time on that? Were we doing okay on time there? Okay, so this is our last one. 2 sine 2 theta equals 1. 2 sine 2 theta equals 1. Now, don't make this harder on yourself and start using the double angle formulas right now. Okay, you do not need double angle formulas because all of your thetas are 2 thetas. It's when some are regular thetas and some are 2 thetas, that's when you have to use your formulas. You've got to get them all the same. Okay, so these are all 2 thetas, so that's totally legal and we're fine. Okay, remember if we want the thetas between 0 and 2 pi, and we've got 2 theta here, what will 2 theta fall between if theta is between 0 and 2 pi? Okay. Then it's going to fall between 0 and 4 pi, between 0 and 4 pi. I just multiply that whole thing by 2, and that becomes 2 theta and 4 pi. So we're going to be going up to 4 pi. Now, that was our, let's see, that was our bell for flex time. So if you feel like you're good on this, if you feel like you got this example and you're ready to go, then you can go ahead and start your Delta Math assignment. But I'm happy to run through one more of these together just to make sure if anybody wants to see a second one. But it is officially your flex time, so you can go either way, okay? Does anyone want to see a second example? Yeah, I figured they would, so let's go ahead and start this second example just and run it through real quickly. All right, so Emily, can you help me with this one? What would I do trying to get the 2 theta by itself? Okay. And that gives me sine 2 theta equals a half. Okay, so we're ready to think about our unit circle. Where is my sine? Positive a half. My y value, positive a half. Okay. Right, at those 2 angles. So this is what 2 theta equals. So 2 theta equals pi over 6. Or 2 theta equals 5 pi over 6. Okay, and that's our first time around the circle. Okay, why am I going a second time around? Because if thetas are going to be between 0 and 2 pi, and I'm solving for 2 thetas, I know I multiply that by 2, and 2 thetas are going to be between 0 and 4 pi. So we've got to go a second time around the circle to get all the way up to 4 pi. So my second time around, let me change colors. My second time around, what are the co-terminal angles for those, Emily? How are we going to find them? Do you remember? No problem. So we find co-terminal angles, angles that terminate in the same place. We find co-terminal angles by adding or subtracting 2 pi. We're going to add 2 pi because we want to get forward all the way to 4 pi. So we're going to add 2 pi. So my question is, what does 2 pi look like over this denominator? Because we're going to be adding fractions, so we want a common denominator. So right now, 2 pi is over 1. I want to see what it looks like over a denominator of 6. Okay, so I'm just going to multiply the numerator and the denominator. I'm going to multiply by 6 over 6, and that looks like 12 pi over 6. Okay, so when I want to find the coterminal angles, I'm going to add 2 pi with a common denominator, and 2 pi with a common denominator looks like 12 pi over 6. Can you see that that would simplify down to 2 pi? Okay, so that's just adding 2 pi. So what's pi over 6 plus 12 pi over 6? So that'll be this one, will be 13 pi over 6. The second time around here, 2 theta equals, we're going to take 5 pi over 6 and add 2 pi, which looks like 12 pi over 6. So 5 pi over 6 plus 12 pi over 6 is, and so that's how we get our 4 equations that we're going to start with. First time around the circle and then second time around the circle. To get the second time angles, you're just adding 2 pi to your first time angles. Okay? All right, and now we're just going to solve those. So the way we're going to solve them is we're going to divide both sides by 2, which is the same as multiplying by 1/2. That gives me theta equals pi over 12. We're going to divide both sides by 2, which is the same as multiplying by 1/2. So theta equals 5 pi over 12. Okay, we're going to divide both sides by 2, which is the same as multiplying by 1/2. So theta equals 13 pi over 12. And we're going to divide both sides by 2, which is the same as multiplying by 1/2. And that gives me theta equals 17 pi over 12. Last step, we want to write our answers all together in one set in order from smallest to largest. Remember, your smallest will come from your first time around. So that's going to be pi over 12, 5 pi over 12. Then we'll go to the second time around. We got 13 pi over 12. And our last one was 17 pi over 12. Okay, now I want to point something out. Once we get them there in order from smallest to largest, let me give you a second. Okay, all of our thetas are supposed to be between 0 and 2 pi. Okay. So what does 2 pi look like with the denominator of 12? 2 pi with the denominator of 12. So now some of you can do this in your head, okay? We're just going to multiply it by 12 over 12. This is just so we can see if we did it correctly. So 2 pi looks like 24 pi over 12. Can you see that 24 pi over 12 would simplify to 2 pi? Okay, all of our answers are less than 24 pi over 12. All of our answers are less than 2 pi, okay? Because we picked up all the answers between 0 and 2 pi. This last thing you don't need to show. This was just me showing that we did get all the thetas between 0 and 2 pi.